A cyclist and her bike have a combined mass of 75 kilograms. On a level smooth road, using her maximum driving force, she accelerates uniformly from rest to 6 meters per second in 18 seconds. Calculate her maximum driving force. So this is the value we want. We want the force. We know that force is equal to mass times acceleration. So let's write this down. Force is equal to ma. Here we're given the mass, but no acceleration is in the question. So what we need to do is to first find the acceleration. And how do we do that? Well, we need to decide which of the SUVAT equations to use. So let us write out SUVAT to make that decision. So in the question here, we can see that the time given is 18 seconds. We want to find the acceleration. That's what we want to find. We have the final velocity, which is 6 meters per second. And the initial velocity would be 0 meter per second. No distance was given, so this is not relevant. So which of the equations we use? Well, we know that V equals U plus AT. So we could use this equation based on the information that we have here. Therefore, the final velocity is 6. The initial velocity U is 0 meters per second. And we want to find the acceleration, and we have the time as 18 seconds. Therefore, we have 18 times the acceleration, or 18a. So we divide both sides by 18 to get the acceleration. So acceleration then would be 1/3 meter per second squared. So we can use the formula now. Force is equal to mass, which is 75 kilograms. I'm going to write 75 kilograms, and I'm going to show you the unit that we're going to get, times 1/3 meter per second square. So what we get there is 25 kilograms meter per second square, which is newtons. So it is 25 newtons. So the force there is 25 newtons. That would be her maximum driving force.